So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, we have started our new series regarding the digital engineering tools, and in our previous videos we have seen some of the tools which are offered by Festo. Now in the upcoming videos we will see some of the tools which are offered by SMC. Now SMC is also one of the leading manufacturer of automation tools like actuators, grippers, shock absorbers and many other things. So here I'm not promoting any kind of brand or manufacturer. My main aim is to show you the different tools and how you can use those tools for the system design. So without wasting time, let's get started. Before going into details, you should know that what will you learn out of this video. So very first thing is what system inputs are required. So whenever you guys design some kind of product or say mechanism, it is very important that you should know what are the inputs that are required for the designing. Let's say you want to design a system in which you have to push a 10 kg load. Now what is the system input here? You know that 10 kg load you want to displace. So this is the kind of system input, and many times it happens that the system is complicated, so you are not sure like what kind of system inputs are required. So at the end of this video you will know that how this digital engineering tool will help you to know what are your system inputs. Then the second part comes is like what output parameters are required to be considered. So whenever you design something, let's say our example 10 kg of load you want to push, so which kind of cylinder you will pick, what will be its bore size. Now the bore size is the output parameter, so this digital tool will help you to decide which bore size you should select, and it will give you some output calculations which will be compared with your input parameters. So that is very important factor that you should know, that whether my system is safe or not, whether my selection is say proper or not. And then the third thing is how to use this digital engineering tool effectively to check the feasibility of your design. So yes, at the end of this video you will definitely know that how this digital engineering tool will help you to find out the optimum solution, because whenever you go to design something there are n number of different options you might have. Then you have to compare and choose. So what if you have a tool which is readily available, and it can give you the results within uh, a very less time. So yes, all these things you will understand at the end of this video, so don't skip the video, watch it until the end. So let's get started. So you have to type SMC product selection tool, and you can see the first option like model selection software. Just click on that and the window will open. Now this is the site of smcworld.com. You can directly go on that and you don't even have to log in into this. So here you can see a lot of options are there, like select from equipment list. We have some of the software, some of the wave tools like power clamp selection, rotary actuators, grippers, electric actuators, and so many other things are available which are totally free, and you can utilize them for your optimum system design. Now today we will see the vacuum absorption transfer system, like the selection of the complete vacuum system. So let's see what it is and how to select that. So just click on the model selection software and it will get open. Now here you can see the target selection series, the precautions, that means on what basis these calculations are done. You can read that. Just click on the next button. Now here you could see the parameters, like first is the model selection and the characteristic selection calculation. So you can see the model selection, the select the system construction. You can see now some of the circuits are here, and there are little bit changes in the circuit, in the orientations and all those things. So you can read these circuits. Now what is the ejector system integrated unit, what is the discrete components, what is the vacuum pump system? So this might be confusing, so here is the solution. You can just read what the system is and what is the explanation, what does it contain, what are the equipments in that. So according to this you can take a you can select the system, like which thing you want. So according to that you can select it. So you can see some are with the integrated system, so in some cases there is a discrete pump and all those things. So let's pick first system, the ejector system integrated unit. Hit next. There it will show the circuit structure, and there is a little bit changes in the circuit structure. You can go with let's see, with release pressure circuit one. You can go with any other circuits according to your requirement. So this is again a system input, and you have to go with that. Then we have selected now the circuit, and here are some of the inputs that we have to give. Now there, this is the lifting type, the horizontal and the vertical lifting. Now you can read that the vertical lifting, please avoid use in vertical lifting application. So it, the system itself recommend you that avoid the vertical lifting, right? So we have the absorption response time, that is the, you can see this time is in seconds. So you can give this response time. Let's say we have 2 seconds. Then the safety factor, you can see the safety factor ranges from 4 to 100, so you should mention a higher safety factor for this. Then the workpiece mass, you have that how much kgs you are going to lift. Let's take 10 kg of mass we are going to use. Then the vacuum pressure, so absorption vacuum pressure. Now this is the vacuum pressure, the quantity of pad, like how much or how many pads you want. Leakage per pad you can mention, that is nothing but the leakage through your pad. And you can read more by clicking on that arrow button. Then pipe between the ejectors, these are the pipe lengths you can give if you know what are the lengths. Now don't confused between the supply pressure and the absorption pressure. The supply pressure is the pressure for the walls and all those things, so that is like 4 bar, and the vacuum pressure is the kind of thing which gets generated inside your cup to lift your part. So that is kind of amount of vacuum that will get generated inside your cups. So you can read the safety factor should be 4 times or more for theoretical lifting force. For horizontal you can see it should be 8 times more for vertical lifting. So according to that you have to change your safety factor also. So let's click on next, or we can just have a little bit higher safety factor, let's say 8, and then just click on next. Then we have options like pad series, we can just go for all so that it will compare all the products. And here we have to give some inputs like pad type. Now what is the pad type? If you don't know, don't worry, uh, you can have the pad unit with adapter with buffer. Now what is the meaning of that? You don't know, right? So don't worry about that, just click on the arrow button or here and it will show you what is the meaning. So pad unit is the only pad, then you have a adapter, that means it will be having some nut for the tightening. Then with the buffer non-rotating mechanism, so if you have a height variation in your job, so that will be taken care by your spring arrangement. So this is a kind of thing over here. uh, then again it has a non-rotating mechanism. uh, then the next one is without non-rotating mechanism, then with buffer balls spline. So according to your application you have to select the pad. uh, you have to select the pad, right? You can read what are the other types or there, if there is an inclined plane and all those things, right? So let's select with adapter. Then the pad shape, you can go and you can check out what are the different pad shapes available. So these are like the system inputs, and you have to check it, uh, like which is suitable for your system. Then let's select flat with groove. Then you have pad size, so we have options like 100 and 125. Pad material, now again there are different kind of options available for pad material. You can check like what options we have. The important is mark free and the blast specification, so you can read what is the meaning of that. And then in the pad material we have different materials like NBR, silicon, rubber, then urethane, FKM. Let's go with NBR with the let's say plus blast specification. So let's select it. Then the threads, we can give the thread option. The vacuum inlet direction you can give, and again you can check what is that. So depending on your space availability and orientation, you can have the entry. So then the vacuum inlet direction, so let's select vertical, and the mounting options are there. And then the buffer stroke, and then the accessories. So with this we have selected our pad. You can see, just click on the next button, and then what we have is the tubing selection of the tube. So let's have, let's say we can go with the polyurethane metric sizes. Then again different series are there, so according to your application you can select the common tube color, you can select length of the roll, you can select. So this is depending on your system type. So let's take solid blue, and the roll is let's say 20 meter. And then the other branch specifications, we will also require some branch tubing. So let's select for that one blue, and again you can select the roll and the type. Now we have selected the tubing. Now let's go to the selection of ejector unit. Now ejector unit is the unit that, like we can say, reduces the vacuum, or after the vacuum we have to release the vacuum, right? So that the part can be the part can be released. So that for that purpose we require this ejector system. Let's see what are the specification. Now here we have the valve type, so you have to select the valve, solenoid valve. Again you have different options. The body type you can select, the exhaust system you can select, the vacuum port fittings you can select, the supply port fittings you can select, the exhaust port we have, then the release pressure supply port, pilot pressure supply port. So all these things you can select, and you have a lot of options you can select from that. So this is the complete ejector system, right, that creates the vacuum and also reduces the vacuum for release of the part, right? Then just click on the next button. So we have completed finally our selection, and you can see the condition inputs what we have given to the system, and according to that what we have selected the item and the calculation values. We can see the precautions on what basis these values have calculated, that you can read. Here we have our part specifications, you can see the dimensions, right, the pad type, which pad type we have selected, we can see over here, and this is the product number. You can check the product number. Then these are the tubing information, these are the ejector unit information. So this will combine all the data and will summarize and show you. So you can check the part number, just click on the blue box so that you can verify the whether the part number is okay or not. So click on that and it will show you what you have selected, and it will show that the details are right. That means the part code is right. The green tick indicates the part is right. If there is something missing or something wrong, it will show error and you can correct that. So that's why it has given. So right tick indicates the product number is correct. You can have CAD catalog, and you can print this data. So it gives the complete system data for the vacuum system, like from selection of pad, then tubes, the ejector unit. So all these products are required for any kind of vacuum system. So this is kind of a software, or a tool rather I should say, where you can see all these things parallelly. Because if you go to design this system, it might happen that you can skip something, but here there is no chance to skip, because as you move ahead the system will ask you for the inputs, and if you haven't thought about that, you have to think about that. So this is the what should I say, beauty of this software, that it make you to think that which type of tubing I should go with, what should be the size, what should be the pad material, and all those things. So that is how this tool is very very helpful, and I recommend you guys that you can take a look of this thing, and it will definitely gives you all the information that we have discussed in the previous slide. Also it will give you the importance of input parameters, the output parameters, and how you can have a optimal feasible solution. So this is it guys for our today's session, and I hope you got some new knowledge regarding the digital engineering tools and their benefits, and also what are the system inputs for designing the system, why those inputs are important, then what are the system outputs, and how to compare these parameters for the optimal selection of your product. So all these points we have covered, and if you have any doubts, please do write into the comment section. We can discuss over there. Until then, keep intro making. Don't forget to subscribe the channel and hit the bell icon for the upcoming videos. Thank you for your patient listening. Thank you.